evening. Can you listen my voice? Please respond. Okay, thanks, Dan. Izian, thank you very much. Right, I'm so sorry. Since 8:30, there is a lot of problem. I think maybe due to the raining. I hope it will be okay. Can you see my face? Camera? Tak ada sangkut-sangkut Right. Okay. If sangkut, please let me know. Right. Okay, tonight is a subtopic, continue topics from chapter number 2, which is about the manufacturing aspect. We continue on the tolerancing. I think you can see from the screen. I'm going to continue and try to explain as much as I can. Lots of definition that you need to understand, because I did some lectures on the same topics for the group section 11 and 12 this afternoon, and it takes I think about 2 hours, as a few minutes, maybe about 50 minutes due to disruption of the internet problem. Hopefully tonight there is no problem on the internet. Okay, right. So tolerancing, I think you still remember few early coming in. Early topics in chapter 2, I did talk about what is the specification and what is the standardization. So basically, you need to understand what is the specs and what is standardization. What is all about? What is the difference between specification? What is the difference between standardization? And then after that, I talk about a mating part. If you still remember, there is a 3 type of solution where engineers use in solving problem in assembly. The first one is a make to suit. In bahasa Malaysia, we call buat sehampir mungkin. And then second is selective assembly. In bahasa Malaysia is assembly pilihan. And we have the third one is intangible manufacture, which is the pembuatan boleh saling tukar. Make to suit examples is a special order parts, special order products. For example, parts for racings. Okay, yang mana memang orang order special. For example, you have a big bike, maybe need to do some modification. If you buy a new one, will be very expensive. Or for example, it comes in modular. Benda tu kalau dia datang dalam modular, it was very, very expensive. So maybe some of the part, if let's say the parts, the module, it consists of 4 parts, maybe only 1 part's damage, you can make a special order, which is less expensive. Okay, more cheaper. Even though it's more cheaper, but it's still expensive. So you can use this kind of method. We call it a make to suit. Okay, tonight I'm going to deliver one of the important topics in test 1, which is we're going to talk about holes and shaft. Okay, this is the examples of shaft. There is a hole. So we're going to talk about holes and shaft, which is a good practice, a good examples in talking about tolerancing. So if you look back, the making to suit, it makes the mating part as close as the machinist can. Okay, for example, I receive one order which asks me to lathe, okay, menggunakan proses turning untuk melarik shaft ini. So if let's say they're asking about maybe 20 millimeters diameter plus minus a few tolerance. So the closer the tolerance, it's mean the high accuracy of the machiners have to produce. And this is, for example, the holes, and we do not know what is the exactly, we know just a little information about the diameter of these holes. We have one shaft. So what the machiners do is that he will try to machine this bar, this rod, until it fits into this hole based on the spec or the requirements of the clients. Okay, that is mean make to suit. Special order. Maknanya memang dibuat sampai mungkin. Second one is assembly pilihan. I did give examples for if we have if you still remember, there is a type A, B, C engine for Honda. So instead of the manufacturer, the fabricator produce the part, instead of rejected, so they will group into a grades. Okay, the higher grades will be in type A, second grade will be type B, third grade will be in type C. But both of them for hole and shaft needs to be fixed together, and they must be in the same grade. Okay, and the third one is intangible manufacture, iaitu pembuatan boleh saling tukar. Example is that we have one basket, 1,000 of nut in one basket, and we have another 1,000 screws in one basket. You can choose any one of nuts, you just pick up any screws, it can be fixed together. Intangible manufacture, we learned about tolerance. There are three types of fits. The third fits, the first one known as a padanan kelegaan, is a clearance fit. So normally clearance fit been applied in the intangible manufacture, yang mana the examples of nuts and screw, which is can fix together without any problem. Just choose any nuts, any screw in the basket, 1,000 screw, just pick up, and then you can just match them together. So this principle, they use a principle fit of clearance fit. Okay, itu yang diguna pakai. Alright. So back to we start with the tolerance. Tolerance been used in order to ensure that the assembly function properly instead of following the exact size, which is impossible for the machiners to fabricate. If you ask someone to fabricate a diameter of 20 millimeters, 20.00 millimeters is impossible. There is no machine, there is no machiner or fabricator can produce that. So what they need is that they need a tolerance. That's why in the second statement, it did mention there is no component can be manufactured to an exact size. Exact size in our study is known as a nominal or basic size. What is a norm size? What is the basic size? If you have 20.250 millimeters, 20.250 mm, the norm size, or we call it basic size, known as a 30 mm, 20 mm, sorry. Okay, the point, the value after point will not be counted. So if anybody asks you, anybody, Nurhanis, what is a norm size, what is a basic size for 30.010, then Nurhanis, you have to answer the question is a 30 mm. Do not write, do not mention 30 point blah 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 blah. 30.000 is still corrected, is still correct. But if you mention 30.010, you will get wrong. You will get 0. For this question, the answer is 1 mark in one of this question. Okay, so you need to understand that. All right, and as we know, the designer, he need to decide what is the upper and lower limit. Upper and lower limits in tolerance adalah had atas dan had bawah. We have this basic size. We have the norm size. Okay, basic size and norm size, you say about 30.000. But to give a tolerance, to make sure the part will not be a loss of reject due to the capabilities of the machine and the fabricator, you need to give a tolerance. Yang mana dia ada had atas, had bawah, where the upper limit is still under accepted, lower limits accepted. Between the range of the upper limits and lower limits is acceptable range, acceptable values where the fabricator can make. All right. So for example, if I say 20 millimeters plus minus, okay, 20 millimeters plus minus 0.100. Okay, 20 millimeters plus minus 0.100. So it's mean that the upper limits of is 20.100. The lower limits will be 19.900. So what is the tolerance? The tolerance is 0.200. Anis, faham ke tak faham?
Faham,
Anis?
Doktor.
Okay. So there will be upper, there will be lower limits. Okay. Macam kita hasilkan sesuatu produk tu, is impossible that we can make exact size. Macam norm size, basic size, 20 mm, 30 mm, 40 mm. It's ridiculous. Nobody can do that. Nobody can fabricate until exact size. So you must give some gap. We call it gap. Okay, gap, it's mean in this gap, if the machinist can fabricate between this range, this value, it will be accepted in the production. Okay, all right. So the accurately the tolerance dimensional usually will take much more time. It's mean any fabricators, if you give the gap a large gap yang besar, for example, you talk about 20 diameter mm plus minus 0.500 compare with 20 diameter plus minus 0.010. So the second one will take longer time and it's not easy to get the product in that range because it's very small gap. The second value gap is about 0.010 plus minus is mean 0.020. Compare with the first one, 0.500 plus minus is mean is 1.00, 1 mm. The second one is 0.020 mm. Okay, right. So this is the examples to show about these tolerancings that been applied in this drawing. You can see this is the housing on the right. Boleh nampak cursor saya tak? Kakak, boleh nampak cursor tak kakak? Mana kakak semua ni? Nampak ke tak nampak cursor saya? Cursor mouse ni, nampak ke tak nampak?
Nampak, Doktor.
Okay, thank you for the response. Kakak semua mana ni? Alright, now, this is a butch. Okay, this is a butch and this is a shaft. So start from now, we are going to talk about, not talking about butch, not talking about housing, but I'm talking about holes and shaft. Okay, these examples is a good examples. For example, this housing, what you can see that housing, if product, we can say like wheel hub. Siapa ada motorcycle sport rim ke yang bukan sport rim ke, you punya motorcycle tu, tengah tu ada shaft tire tu, tire, wheel, ada dia punya jari, lepas tu tengah tu dipanggil wheel hub. That wheel hub, this one. And you see this is lubang. So what happened is that there is a butch. Mesti ada butch. Kenapa ada butch? Because the friction is between this butch and this shaft. It's not between the hub and the shaft. Why? The hub is made from casting. Okay, the butch is normally made by forge, by metal forming, so it can stand the friction, high friction. But in normal practice, they use a bearing. But not motorcycle biasa tak ada bearingnya. Dia pakai bush je. Okay, yang biasa ada bearing ke? No bearing. It's just a bush and wheel hub. Yeah, which is much more cheaper. Okay. Alright. Okay. So this tolerance is allowance, okay, on the specific variation in the size and geometry of part. They are the variation there. Okay. So as we know, there is no component can be perfect, okay, because of the manufacturing process. So we need this tolerance. Okay, we need the tolerance. And this is another examples, more advanced example. You will see that there is already have the upper limits and lower limits. And in this figure, it shows very clear where there is a upper limits and lower limit being applied at this housing, this butch, and this shaft. Just to remind that if you look at this butch, as this shaft, and as well this housing, you will see that the values of the upper butch and also housing, sometimes you will see that it cannot be fixed. Okay, for examples. Tolong tengok ni. For example, 25 maximum. Okay, that is the range. It's not exact size. This is the range. Okay, now I want to test. Amar, are you listening, Amar? Amar, are you listening? Amar, where are you, Amar? Please come.
Okay.
Okay, Amar. Tengok dekat ni gambar ni. Now, I asking you. This is the size, maximum size and minimum size of butch. Maximum size, upper limit is 25.100. Lower limit, minimum size of butch is 25.075. My question, what is the value for basic size or nominal size for this butch? What is the answer, Amar?
Maybe
Huh? Apa jawapan dia?
25.
Apa slow benar ni? Suara kuat sikit, Amar.
25.009, I guess.
Alah slow je suara Amar, macam cakap dengan couple. Type. Type dekat tu, dekat message tu. Tak berapa clear. Apa jawapan kamu? Dah type belum, Amar? Dah type belum? Diam terus, Amar. Amar mana? Okay. Alright. He said 25.9. Thank you, Amar. Tapi saya nak jawapan yang lain. Muhammad Aiman. What is the basic size or nominal size for this butch? He said The upper limit was 25.100. Minimum is 25.075. So what is your answer? Muhammad Aiman bin Muhammad Tamizi. Are you listening?
25.
Okay. Alright. Thank you. Amar. Jangan tidur. The answer is 25. I did mention just now. I did told you. Do not mention the value after titik. After point. Saya bagi tips terus. When people ask you what is the basic size, norm size is 25. Same goes with housing, 25 as well. Okay, now Lau Zeng Hong, are you listening?
Yes, doctor.
Okay, for this butch, for this shaft, what is the norm size and basic size for the shaft?
15 millimeter.
15? You say 15? You say 15?
16 lah.
16, 9? 16?
16. And
Boleh negotiate lagi?
Tak apa. 16 lah.
Okay, so which one? 15 or 16?
I choose 16.
Okay, thank you. Correct answer. So you get 1 mark. Every of you, if you answer correctly for this question, you get 1. So it's a 16. Okay. 15 ni, even though it's a maximum, it cannot be 15. It should be 16. Tengok ni. Okay, dia bagi sini kan, diameter kat sini. So it's a 16. Alright. Tak apa, slowly. Kejap lagi kamu akan faham. Right,
Sorry,
now.
doctor, I have a question.
Yes.
What happens
Yes.
if the lower limit is 15.4 but the upper limit is 16.2? Then the nominal should be which?
Okay. For this question later, you will check because for this tolerance, okay, it cannot simply, it's not intolerancing in this subtopic. We must understand this is a limits and fit. It's not depend on us. Okay, it did not depend on us. There is a match between holes and shaft size. Following the BS 4500. Later, I will let you know. So we are not choosing the size. I mean, from us. Let's say, okay, I want to put 16.5 and another one is 15.5. No. There must be basics or norm size. Just in this case, in this example, I just ask you, okay? So this is a standard. Please be reminded that in this topic, limits and fit, there is a standard. It's not, the dimension is not comes from us. Is what we call it a match between holes and as well the shaft following the BS 4500. Later there will be a slide about that. Okay, don't confuse. Okay, don't confuse. Okay, now, so tolerancing being used. It said the good engineering practice finds the optimum balance between the required accuracy for the function of the component and minimum cost of manufacture. This statement is very important. Even though in this subject, in this topic, it's more on the calculation, but you need to understand. Okay, the minimum of the tolerance is mean the higher of the accuracy. The more complicated to the fabricator, the more complicated or expensive machine will be used. Okay, if you fabricate the higher tolerance, okay, the cost of manufacturing will be less. Simple to understand. I did give some example this afternoon to the section 12, 11 and 12. If you buy a JCB, you know the JCB, nak buat korek tanah dan sebagainya, it was very cheap. Okay, compare with a small car, it costs a few 100,000 ringgit. Why? Due to the precision. Okay, if you drive Honda City VTEC engine, a new one, you cannot hear the sound of the engine due to high accuracy of the component of part of the engine. Okay, sometimes when you go into the car, sometimes you try to start it again because you didn't listen. You cannot hear the sound of the engine. The indicator is only RPM in front of your meters. You can see the RPM, rotate per minute. Okay, then you know the engine is already started. So based on that, the JCB, if they just drive through in front of you, you will listen a lots of noise. Kedegong, 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 kedegong. You know, all the benda alat depan tu you will see is shaking around, shaking due to the tolerance. Okay. Okay, this is examples of drawings where it shows where the tolerance been applied. There is a plus minus, you know. In this drawing, it shows everything about the units, the components, the drawing numbers, the material specimen using British Standard 970, everything. Okay, is there. And this is the to show how the tolerance been applied. Okay, if you look at the design concept from the designer, it just give the exact dimension. It just give a nominal dimension. Okay, it just give you 20 mm size diameter. It just give you 25 without mentioning the tolerance. But when it goes to the manufacturing specification B, okay, when it goes to the production, engineers need that tolerance. If not, they will not fabricate the request. I mean, from the designer. No, because it's impossible to fabricate. So if you look at this, the black color and also the celoring one, this is showing the tolerance. Okay, the gap, the allowance gap to make sure that the fabricator easily to fabricate and the product or the parts will be acceptable. Okay, so you see that there is the higher limits, lower limits of shaft, and they have this tolerance. Same goes with the hole. There is a upper limits, there is a lower limit, or sometimes they call it a minimum size of hole, maximum size of hole, and we can see there is a minimum clearance. Minimum clearance in bahasa Malaysia adalah kelegaan minima, okay, in between a maximum size of shaft with a minimum size of hole, and you can get the maximum clearance, which is between minimum size of shaft and the maximum size of hole. Okay, that's why I need all students to understand this. If you not understand, ask me to repeat. Okay, if you not understand it clearly, you will lose 10 marks in the test one. 10 marks is very banyak because normally in test one, your marks is about 50, maybe 48, maybe 45. You will lose 10 marks. It's approximately about 20% you will lose. So be careful. Okay, and on the right side, the conventional diagram of fits is just to show some portion of the tolerance being cut and put into this. Later, you will see there is a table to show a similar format where this is one of the examples. Okay, hanya sketch saja nak tunjukkan how they apply in the table. Okay, this is the basic size, which is means 0. And this is the what we call it the acceptable range for the tolerance for the holes, and below black color is the acceptable tolerance range for the shaft. Okay, this is the general tolerance notes to show states in the drawings. Okay, plus minus 0.1 is like this. Okay, this is another examples. We can see that a different way, different approach of showing the upper limits or lower limits in the drawings. Okay, you can see the top one, it shows the maximum minimum limits of size. It's written like this: 32.15, 31.80. Okay, and the other one is 32 plus 0.1 minus 0.2. Okay, this is just an examples. Some of them just show 2.0 plus minus 0.025. Okay, so now, all right, against basic size or norm size is the size of shaft or hole that designers specify before it been applied in the limits in the production drawings. Okay, against, I repeat, is the same with the previous slide. Basic size 25, 30, 40, 50, 100, 200, known as a nominal size as well, is the size of shaft or holes which specified by the designer. But in the production, no, we need the tolerance. In tolerance, there is an upper limit which it is show the largest, the maximum size of shaft or hole, and there is a lower limit which is present for the smaller size of hole and shaft, or sometimes they call it a minimum size. Okay, and against the tolerance is a difference between upper and lower limits. Okay, and this variation from the size and norm dimension, they sometimes call it bilateral and also unilateral. Okay, later I will show you, there is a slide about this. Okay, and deviation of is said algebraically different between the size and the corresponding basic size or nominal size. Later on, you will see what is a deviation. Deviation is a difference between the basic size. Okay. Okay. In this slide, it's very important. Okay. Now, in this limits and feet, first thing you need to understand the definition. Most of the students, when they answer question is easy, but the misunderstanding due to this definition, they will answer it wrong. Okay, be careful. So again, in feet dalam bahasa Malaysia is padanan. Okay, in feet, there are three types of condition. Okay, between a mating shaft and hole. Maknanya, dalam kita nak fitkan ini hole, ini shaft. Tengok dekat sini. Okay, nak fitkan benda ni. Nak fitkan shaft masuk ke dalam lubang, ada tiga keadaan. Yang pertama dikenali sebagai clearance fit. Okay, number one is clearance fit. Dalam bahasa Malaysia kita panggil padanan kelegaan. Second is a transition fit. In bahasa Malaysia kita panggil padanan peralihan. The third one is a interference fit, which is known as a bahasa Malaysia as a padanan gangguan. Okay. If you look at the clearance, how do you know it's a clearance fit? How do you know? Okay, after the previous slide talk about tolerance, upper, lower, deviation, many things. So now, how we know clearance? Simple. The size of the shaft is always smaller than hole. That will be clearance. When you calculate, you will get maximum clearance positive, minimum clearance positive. It means that like this. The condition, you see this shaft, you see this hole, easily to be in and out. Understand? Haris, faham ke tak? Faham ni Haris? Haris Zikri. Haris Zikri, where are you?
Ya, Doktor.
Faham ke tak faham?
Faham.
Okay, now that is a clearance. Similar goes with the JCB. You know the JCB bawa jengkau tu kan godagang-godagang, bergoyang-goyang belakang dia sebab clearance. Clearance fit, padanan kelegaan. Okay, Then the second one, transition. I'm not going to talk transition first. I straight away to the interference. Okay, now tengok interference. Interference ni padanan padanan gangguan. Padanan gangguan ni bermakna the size of the shaft, the upper and lower, is always bigger than the hole. Maknanya size dia sentiasa selalu lebih besar daripada size of hole. Maknanya dia punya minimum size of aci tu, minimum size of shaft is always bigger than the maximum size of hole. Jangan fikir kata you say, doktor, it cannot be, tak boleh masuk ni, tak boleh berfungsi ni. Tak, dia boleh berfungsi. Cuma we are talking for 3 decimal. 3 titik perpuluhan. So, if you talk about interference, clearance, this is a shaft. Boleh masuk easily. Okay? Easily to be in and out. So now, when you talk about interference, it cannot be. Macam ni, you tolak tak boleh masuk. Tak boleh, cannot be in. You must have a special machine. Okay, special machine. Yang mana you gunakan seperti hydraulic press. Tahu hydraulic press? Macam mana orang nak fixkan bearing. Nak letakkan bearing pada certain lubang yang mana kena tolak, press fit. Orang panggil press fit. Tolak slowly. Tak boleh knock, tak boleh. Ketuk, tak boleh. Takkan masuk punya. Okay, contoh macam bearing. Yes, if you can use, that one is very expensive. You gunakan satu liquid nitrogen untuk sejukkan dia, untuk mengecutkan dia. Itu tujuan dia. Lepas tu you boleh masuk easily. After the temperature going up, dia akan duduk pada saiz asal balik. Itu tujuan. At certain area, they will use that. But normal area in Taman U, kat mana-mana dalam Malaysia, orang akan guna press fit. Okay. Buka pun pakai tu. Tolak, keluarkan bearing. Contoh bearing hub kereta tu. You buka tayar, you buka caliper, and then you have to pull out the wheel hub. Wheel hub, you go to the machinist, they will open the old bearing by using the press fit. Pakai hydraulic tu, tolak bawa keluar. Kemudian masuk yang baru, pelan-pelan. Bukan boleh sebarang-sebarang ketuk. If you ketuk, guna hammer, the wheel hub is made from casting. So casting cannot stand any high hammering punya ni, tak boleh. It will be cracked. Sometimes they put kayu, ketuk pun bahaya juga. So that is one of the examples of interference. And some of them will ask, what is the condition after we fix by using the interference? It's similar to welding. It's similar to weld. Dia punya strength dia sama macam weld. Sangat-sangat kuat. If you see there sometimes lorries, you just put aside of the highway and you nampak ada long shaft jatuh kan, ada long shaft which break down like that, you will see due to the bearing, which is broken bearing. The outer size of bearing, the ring is still in the bearing housing, but the ball bearing is broken. Kuat tak kuat is very strong. Nampak tu dia punya tu. So have to use. That is a interference. Okay, now the transition interference calculation, if you calculate what is the maximum interference, minimum interference, it will be both negative. Transition, no. One positive, one negative. It got one, we call it clearance fit. Another one is interference fit. One positive, one negative. Okay, now. Tengok semua sini. Aiman, Senevi, Zuhair. Tengok sini. On my finger, on this side, this is showing the tolerance, accepted tolerance range for hole. On my right, I don't know your left or your right, this one. This is showing the range, acceptable range for shaft. Now, in this position, which is the maximum, the upper limit, this is the upper limit of shaft, is always below, which is smaller than the minimum size of hole. It's mean clearance. But if I put this way, which is the minimum size diameter of shaft is always bigger than the maximum diameter of hole, it's mean interference, padanan gangguan, okay, at this position. Now, I want to talk about transition, how it look like. It's like this. Transition will have three condition. Tengok shaft ni. Shaft punya tolerance. It will be number one at this position. Second condition, it will be like this position. The third position will be like this. You will get one positive, one negative. Okay. Jangan tanya lagi, doktor macam mana? We will see after few slides. There will be calculation. Then you will understand. Alright. Now, kita move. In tolerance, IT is an international tolerance grade. There are 16. IT1 to IT16. Okay. For this IT number, they have the same relative level of accuracy, but they are varies, which is depends upon the nominal or basic size. IT1, IT16, the application is different because the performance of the manufacturer to produce those IT1 to IT16 is different. You will see later. Okay. Later that, okay, I show you senang kot, tunjuk senang. Nanti kan susah. Okay. Where is the IT? Belakang jauh sangat. Okay, this is about IT1, IT16. Okay, this one. This is IT, International Tolerance Grades. You know the IT1. Okay, the class of work and process like slip blocks, reference gauge, which is high accuracy. You see the tolerance for sample size over 3 to 6 mm is about 0.001 mm. Dia punya hasil dia. For size over 120 to 180 is about 0.0035. Compare with IT16, which is made from sand casting, flame cutting. For size 3 to 6, even is small, but the range, the possibility to have a good tolerance, no, for casting. It's about 0.750. Why? It's 1,000. We have to divide it 1,000. So 0.75. And if you look for the oversize, about 120 to 180, is about 2.5 mm. Okay? Nampak? Okay? About the IT grades. Wait. Someone is joining, is it? Yeah. Okay. No. Okay. Right. Back to the okay, now next about hole basic and shaft basic system. Okay, guys, listen carefully. In BS 4500, we are going to talk about this we are going to use hole basic and shaft basic system. If you look at the hole basic system, this system is related to the basic or nominal hole size. And the second one, shaft basic system, is fixed, which relate to the basic or nominal shaft size. Straight away. See this one? Nampak tak dekat depan ni? Nampak? Saya ada tunjuk slide ni. Okay, this one. Nampak tak? tolong menyaut. Saya tak berapa nampak you all nyaut ke tidak. Listen.
Nampak doktor?
Thank you. So now, this is a whole basic system of feed. Try to understand. Apa maksud ayat tadi? Whole basic system, it will relate to the norm size and basic size of whole. It's mean what? Norm size, basic size of whole has been fixed, fix, fixed. You talk about, it doesn't matter, 30, it must be 30 plus. Because the minimum size will be similar to the basics or norm size. It's a 30. 30 plus 0.120 is mean maximum size is 30.125, something like that. But the norm size, basic size 30. So that one is mean the minimum size has been fixed. So we're going to follow normally it will follow the whole basic system. Sebab itu you tengok kat sini, you will see that the size of the hole has been fixed, but the range, the size of the shaft is varies. Okay, now, if you look at, okay, same this one. Hole basics is been fixed, the shaft is varies, it's moving. Now, if you go to the shaft basic system, the size of shaft has been fixed, is follow the norm and basic size. It means if let's say the shaft is 30, then it's 30, for example. But the size of shaft, size of hole is varies from positive to negative. Okay, it's moving. That is the meaning of this definition. Okay, all right. Where for the whole basic, the size of holes is been fixed, but the shaft size is adjusted. The shaft basic system, the basics and norm are following the shaft, but the size of holes has been adjusted. Okay, right now. So as we know, tolerance is very important because it's impossible for manufacturer to fabricate following the exact size. This must be known. And the large of the variation may affect the functionality of the parts. You know, I did mention about the engine type A, B, and C. So the smaller variation, you need a precise manufacturing process. And then another thing is the inspection, and they confirm there will be a lot of rejection due to the minimum variation, very small variation. Okay, so the functionality assembly, for example, parts will often not fit together if their dimension is said do not fall within a certain range of value. Okay, in assembly, we have the range. If you got the size, it's not between that range, it's rejected. Intangibility is one of the principles that been used in mass production. Okay, where to make sure we can get less or zero rejection. Okay, and if you look at the relationship between the functionality and the size shape of the object, is varies from part to part. Okay, so it depends. Okay, depends. So now we are talking about standard BS 4500. We talk about three type of feeds: clearance feed, transition, interference. Again, for economics, we use the intangible principle, intangible manufacture. Kau boleh saling tukaran. Okay, where this principle is easily for the production of the manufacturer to produce part, formatting part, in assembly. So again, as I did mention previously, if there is a too big clearance, the clearance between the upper size of shaft and the lower size of hole, what happens is that you will produce vibration, high vibration. So that's why when you have the old car, you know, 1975, you didn't do any modifications, still use it, there is a vibration. You buy a new car, less vibration. You know, in the engine, there is a high friction. That's why they use a bearing even if they use a slide bearing or ball bearing, there is a friction. Why? Due to the tear and wear. So how they want to reduce the friction? There is still a friction by applying engine oil. Engine oil, at the first place you pour into the engine, is a clear color, very nice engine oil. But after a few thousand kilometers, you will see the engine oil is turning into colors, into dark colors. That dark colors is a serbuk besi due to the friction. Okay, that's why you need to change oil regularly. You want to have a good engine oil, it will be very expensive. If you want to buy a cheaper oil, for sure you can use it, but need to change. Kena selalu tukar lah. You use this fully synthetic 8,000, 10,000 kilometers for car. But if you use normal engine, maybe 3,000, 4,000, you have to change. As long as you change frequently, then it will be okay. That is the theory. Simple as that. Same goes with motorcycle. When do you want to change? You have to check your engine oil, kelikatan dia. Janganlah sampai dah gelap-gelap baru nak tukar. Sebab itu sometimes there is no pickup and engine will be high vibration. Due to that, if the motorcycle is already 10, 15 years old, even though you use a good oil, there will be vibration. So how to reduce the vibration? You have to change the bearing. Ask the powerman to open, overhaul, change all bearing, rod, all change. You will get like a new engine. Okay, this is the theories, that is the application. Okay, now you understand why. This is the examples. Okay, how the oil being supplied in the engine. Okay, this is the way. Okay. All right. So as we know, the tolerance is the difference between a maximum limit and the minimum limits. Okay, sekiranya terputus, we cut off, then I will give you the new link. Okay, all right. Now, speed is the relationship between melting part. Is say we respect to the amount of clearance and interference or interference. That is the things that I tried to explain previously. Okay, the amount of clearance and interference. Okay, in assembly. And when we talk about hole, normally we are focusing for internal. Okay, shaft designated all external features. Okay. Okay, now upper deviation, difference between the maximum limit of size and the corresponding basic size. I will show you next slide. Lower is the difference between minimum with the basic size, the limit size on the corresponding basic size. Okay, the grade tolerance, as I showed the IT, it shows the group of tolerance with the same level of accuracy for all basic size. Okay, clearance is different between the size of the hole and shaft in positive, interference in negative. Okay, now this is the definition. The previous slide said that the upper deviation is between the upper limits of hole with the basic size. This is lower deviation between the lower and the basic size. If you look at this shaft, okay, this is the upper deviation between the upper limit with the basic size, and the lower deviation is between the lower limit and the basic size. Okay, and there is a minimum clearance as well. It shows the minimum clearance. This is clearance, clearance feet. Minimum clearance is between the lower and the upper limits of shaft, and the maximum clearance is between the upper limits of hole and minimum limits of shaft. Okay. Same, this is the other direction. All right. This is the unilaterals. You know, just now did mention this is, for example, unilaterals. Okay, both side minus minus or zero. It shows the both side. Okay, this is bilateral. Okay, you will see that it show plus minus. Unilateral, both side is the same. Okay, this one. Positive, positive, negative, negative. This is unilateral. Bilateral, tak sama. It's not the same. One is positive, one is negative. One is positive, one is negative. There is one question previously. I do not know when is it, but I saw there is a question asking about the difference between unilateral and bilateral, and you need to sketch. So you need to sketch, give some examples between unilateral and bilateral. Then you will get the full marks. Okay. Okay. In the fundamental deviation. Okay. Can we take a break for 5 minutes, guy? I need a break. I need to have some drinks and rest for 5 minutes, and we will start back at 9:30. Is it okay? Okay, all right. Take a break for 5 minutes. We're going to continue at 9:30. Right. Can we continue? Semua dah dinner ke belum ni? Semua dah dinner dah? Saya belum lagi. Baru nak makan. Tengok saya makan apa. Tengok ni saya makan apa. Tak nampak. Nampak tak? Saya makan ni je. Makan fries. Terkejut Nantilah ada rezeki nanti saya belanja. Alah macam sedih. Kenapa Alif Star? Saya makan fries and saya makan apa nak panggil tu ayam goreng sikit-sikit lah. Saya tak berapa makan sangat semenjak I came back from Thailand. Now is my second week try to recover. So berapa makan sangat. Makan tapi berapa sangat lah. Tapi makan benda-benda macam tu lah. Benda yang saya rasa saya nak makan, saya makan. Saya tak nak makan nasi macam banyak. Tak nak. Nanti ada rezeki nanti saya belanja you all. Ingatkan saya. Right. Okay, sorry lah tunjuk makanan. Ada yang tak makan lagi Sorry. Sometimes tu perlukan break sebab nak tarik nafas. Saya kena minum air. Saya pasal itu dehydrated kan. Then I know lah. Dehydrated, anxiety macam. Okay, right. Tak apa. Okay, we continue. Okay, now. Fundamental deviation. British Standard 4500 ni. Dia ada 27 deviation. They have a 27 deviation for the holes and 27 deviation for shaft. For the holes is a big capital A, B, C up to ZC. For the shaft is small capital A, B, C, D up to Z, sampai ZC lah, but it's a small capital. Okay, now. Okay. So if you look at this figure, it shows that start from A. Okay, you can see the range of hole, which is start from positive A, big capital, okay, to the negative. This will be the negative ZC. Okay, this is for, okay, now. Jangan confuse bukan dia duduk macam ni atas bawah. Tak, dia nak menunjukkan sebenarnya dia sama je, zero line, cuma nak tunjuk this is a hole and this is the shaft. Shaft which is a start from A here and it's go up like this. From negative and then it will be positive. So doktor, macam mana tu positif? This is a zero line for hole, this is zero line for shaft. And ini lebih kepada penerangan it just explain. Nothing to do with the question for the answering question ke apa, tak ada. It's just to show how the deviation for whole range and as well for the shaft. Okay. And this is about IT. I did explain. Okay, this is IT grades. Now you know why is it, there is a apa ni? Contoh, you nampak ni tak? You can see this one H8 F7. So what is a 8? What is a 7? 8 ni is IT grade. If you still remember, there is a 1 to 16. Okay, and then the H is the fundamental deviation. Okay, so now the fundamental deviation for H, this is a big capital. So this is a fundamental deviation for hole. F, small f, is a fundamental deviation for shaft. 8 is a IT grade, 7 is IT grade. Okay, for the value, for the numbers. So normally dalam dia punya padanan, we call it feet. In the feet, in the padanan, it will be like this. 20 mm diameters, H9, D10, where the H is a fundamental deviation for the hole, D, small d, is a fundamental deviation for shaft, 9 and 10 is a tolerant grade. 9 is for the hole, 10 is for the shaft. That's it. Okay, now, I'm not going to explain this one. Okay. This one as well is again is the same. It must be feet. Dia ada feet ni padanan lah. For this one, okay, now there must be hole first. Let's say 45, H7, P6. It means H big capital should be in front. It must hold dulu. Mesti hold dulu. Hold, then it will start shaft. Okay? It must be like that. Okay, I'm not going to explain this again. Clearance feed, transition feed, interference feed. I did show some examples in the earlier of the class. Okay, this I did mention just now. You can read by yourself this one. No problem, not to worry. Okay. Okay. Okay, now we start for the calculation. Okay, lama pula ni. Boleh lebih daripada 1 jam Kenapa Bukan ke 1 jam aja. Tak apalah, boleh lebih 1 jam pun tak apa. Kalau terputus nanti saya bagi link baru. Okay. Alright, please look at this. There will be 3 examples. Clearance feed, transition feed and interference feed. Kita habis ni, we finish this one. I will give you quiz. Try to answer later on, or I try to get some of the examples of question. I try to use Google Meet to do some sketch, but I do not know how to use it. I did show just now. I try my best. If possible, you can see from the sketch. I don't know, because normally I use the Webex. Okay, now this is clearance feed calculation. Okay, first thing, 30 diameter is 30 mm, feed is H7 for hole, C11 for shaft. Okay, now my question. Okay, my question. Izian, are you listening?
Yes, Doctor.
Okay, please answer my question. What is the norm size or basic size for this? Izian kat mana? Izian, what is the answer?
Which one, Doctor?
Which one? Inilah ni case study ni. Soalan ni, saya tanya Izian, apakah nilai bagi saiz bagi asas bagi lubang kaci, tak kisah. Okay, katakanlah I will say what is the size asas bagi lubang. Size asas is basic size. Size normal adalah nominal size. Bagi case ni, what is the value?
30.
Apa?
30.
Pandai pun. Okay, thank you. 1 marks for Izian. Correct answer. Harap semua faham kenapa Izian jawab 30. Remember the definition. Ataupun saya bagi tips, do not mention the numbers or the value after titik. After point what, do not mention. So, the norm size, basic size for this aci and also lubang is 30 mm diameter, for example. Okay, now, next question, they will ask you what is the upper limits and lower limits for hole and shaft. Not to worry, in this question, they already give you. But normally, we have to check from the table that they give. So from the table, I will teach you later how to read. Okay. In this case, what is the upper limit of hole and the lower limits of hole? Arif Hakim. Arif Hakim, are you listening? Arif Hakim, where are you? Arif Hakim, are you listening? Bahaya ni kalau tidur ke apa ni. Tak boleh jawab soalan ni nanti ni. Arif Hakim. Tak dengar. Adelan, where are you Adelan? Muhammad Adlan, are you listening? Muhammad Adlan, are you listening? Tak juga. Ini semua saya point nama-nama ni saya ingat ni. Nanti saya nak tengok markah ni. Azimi, where are you? Ya, Muhammad Arif. Kamu Muhammad Arif apa? Arif Hakimi. Betul. Arif Hakimi. Answer my question. What is the upper limit and lower limit for the hole? Untuk lubang, apa saiz dia? Saiz had atas dan had bawah.
Untuk upper limit positif 0.13, untuk lower limit 0.
Okey, pandai. Okey, untuk dia punya dimension, full dimension berapa? Sebut full dimension dengan dia punya basic size dia berapa? Upper limit? Maximum size dia apa? 30 point?
30.13.
Okey, the lower limit is?
30.00.
Okey, pandai. Okey, good. Thank you. Okay, now next. Aziz, where are you Aziz? Muhammad Aziz.
Ada.
Okay, Muhammad Aziz, answer my question. What is the maximum size and minimum size of shaft? Aci tu, apa size maksima dengan size minima?
Maksimum dia 30 minus 0.11. Wait. Minimum dia 30 minus 0.24.
Betulkan balik. Betulkan balik. From the table, the upper limit point is minus 0.110. Okay, understand that. And the lower is minus 0.240. But in correct way to answer the really dimension for this shaft is that you need to, you cakap tadi apa tadi? 30? Apa you cakap tadi?
Yang mana tu?
Kamu jawab tadi apa? Kamu jawab 30 minus?
Saya tak kira lagi tapi cara kira dia kita minus tu lah.
Okey, betul, pandai. Saya ingatkan kamu sebut balik tu. Sebab tu kalau kamu sebut itu adalah pengiraan, yes, it's correct. So Arif correct? Arif pula. Siapa yang cakap tadi? Haris ya? Sekejap. Saya pun dah confuse banyak sangat nama ni. Oh, Haziq Haziq kamu jawab tadi Haziq? Okay, now betul. It's true where the 30 diameter mm you need to minus 0.110. And then the lower limit or the minimum size is 30 minus 0.240. It means the exactly dimension for maximum size of shaft is 29.890 and the minimum size of shaft is 30.760. Is it clear? Aziz, betul Aziz Betul Aziz?
Boleh ulang balik tu? Kat mana tadi?
Betul tak saya kira tadi tu? Sebab kamu kata minus tu saya kira lah betul lah tu kot. 29 point. The maximum size of shaft is 29.890 and the minimum size of shaft is 29.760. Sekejap, macam mana nak conteng ni? Saya nak conteng, I want to write something. Okay, boleh nak? Allah. Itulah, saya tak boleh conteng ni, masalah dia. Kalau saya conteng, dia berubah. Kalau saya conteng kat sini, macam you tak nampak. Nampak tak apa yang saya conteng? Nampak
Nampak.
Ingatkan tak nampak, saya salah conteng. Okay, now. This 30. Tapi dia hilang lah pula Apalah. Okay, 30 minus this one, you get 29.890 mm. 30 minus this one, you get 29.760 for the minimum size. So thank you, Aziz. Then, normally for the next question, they will ask you the tolerance. Okay, the value of the tolerance. Okay, saya nak orang lain. Nur Aziza Batrisha. Aziza, where are you? Nur Aziza, are you listening?
Ya, doktor.
Okay, cepat jawab. What is the tolerance for hole? Berapa? Kira cepat. What is the tolerance for hole?
0.13.
Okay, pandai. Thank you. Okay, next. Nur Fadilah. Fadilah, where are you, Fadilah? Fadilah. Nur Fadilah Hashim. Are you listening? Fadilah, dengar ke tak Fadilah? Fadilah pun dah hilang dah. Najiha, are you listening, Najiha?
Yes, doctor.
Okay, what is the answer for tolerance for shaft? Apa tolerance untuk shaft, apa dia?
0.13 juga. Salah dah.
Ha?
0.13 juga.
Yes,
13.
yes. So 0.240, you minus 0.110, correct? Betul ke?
Betul-betul.
Okay, thank you. So dapat full marks. Okay, now the last question, normally pecahan nombor 4, the fourth question in this topic, normally been asked. They want to know whether is it clearance or interference, normally, or transition. So how to tackle this question easily? First, you tengok, you go and see, check, because you already calculate what is the maximum size of hole, minimum size of hole, maximum size of shaft, minimum size of shaft. Guna ni tang jari saya ajar ni. Tengok tu. 30.013 and then 30. This is for hole. 30.000, 30.130. Shaft is 29.890. It's below than 30.0. Memang macam ni kedudukan dia. Betul tak? So now, Roshaida. Roshaida, are you listening? Roshaida Irdina. Dengar ke tak dengar? Roshaida, where are you? Dengar ke tak dengar?
Dengar, doktor.
Okay, now tengok ni. This is the accepted range of tolerance for hole. Size lubang minimum, maximum. Ini shaft. Sekarang ni kalau ikut pengiraan kita ni dia duduk gini. Is it clearance, transition or interference? Mana Roshaida? Cepat. Ini size lubang. Paling tinggi, paling rendah. Ini adalah aci, shaft. Aci selalu masuk dalam lubang. Dia duduk kat sini. Apa ni? Padanan kelegaan ke, peralihan ke atau gangguan?
Interference.
Interference?
Sorry.
Ini kakak tengok ni kakak. Kakak tengok sini. Jangan main teka-teka, nanti jawab salah. Ini lubang. Ini minimum paling kecil lubang. Ini minimum maksimum lubang. Size dia. Maknanya kalau machinist tu dia buat lubang, dia korek lubang, mesti dalam range ni. Kalau terkecil lubang, terlampau kecil sangat, apa ni tidak diterima. Terlebih besar tidak diterima. Dia mesti dalam range ni. Sekarang ni lubang, ini aci. Aci ni shaft nak masuk dalam lubang. Kalau dah maksimum lubang aci lebih kecil daripada minimum size lubang, kelegaan ke, peralihan ke, gangguan? Cepat Rosada, penat dah ni, lenguh tangan ni. Apa jawapannya? La ilaha illallah. Ada jawapan ke tak ada jawapan ni? Lenguh tangan dah tak larat dah. Apa jawapan dia? Rosada, cepat. What is the answer?
Clearance.
It's a clearance. Senang aja kakak nak tahu. Tengok definisi tadi. Tengok apa saya cakap. Now, this is the minimum size of lubang. Saiz lubang paling kecil macam ni aci paling besar duduk bawah dia. Maknanya boleh masuk. Boleh. Jangan lupa. Satu lagi, kenapa kakak nak pening? Kakak tengok kat atas ni, dah tulis dah pun. Saya saja je tanya. Kan dah tulis kat atas ni, examples of clearance fit. Kan dia dah tulis dekat calculation tu, maximum clearance, minimum clearance. It is a clearance fit. Aduh, tak apa. Now dah tahu kan? Setiap kadang-kadang kalau kita tersalah faham, biasanya for the next time, kita tak ada buat kesalahan. Mesti kita dah teringat apa yang kita ni kan. So, semua orang kena ingat benda tu. Simple. Now, apabila you go to the next slide, dia menunjukkan transition fit. Sama je macam tadi. Sama je. Saya tak nak tunjuk pengiraan ni. Sebab benda yang sama. You need to, you kena tahu what is the, apa kita panggil? Allah. What is the basic size? Norm size is 30. Then try to get the, the upper limit, lower limit values and then get the size. So in this case, you tahu. And then you calculate the tolerance berapa. Nombor 3 kan? Tolerance. Nombor 4 apa? Now, is it transition, clearance or interference? Ya, dekat sini dah tahulah. Doktor cakap tadi example is transition, is confirm with transition. So, macam mana kita nak tahu transition? Guna jari ni balik atau you can sketch, you boleh tulis. You tengok nilai pun dah tahu dah. Nilai pun dah tahu. You cuba tengok dekat situ. Tengok sini. Tengok sini. Tan Kim On. Are you listening?
Yes, doctor.
Okay, please look. Tengok ni. How do you know the transition? Tengok value ni. And then tengok value ni. Okay, now yang pertama 0.21. Kita letak kosong whole dimension. Kosong dekat sini. 0.21. Tapi dia hilang lah. Macam mana nak kekal Apa yang saya nak tunjuk ialah you will see that this value. Sebab apa boleh tunjuk? Sebab ni positif-positif boleh tunjuk. Nampak ni? 0.15 bawah 0.21. 0.02 atas daripada kosong. You tengok ni jari saya. Tan.
Boleh.
Satu macam ni lubang. Sekarang ni aci punya range duduk kat sini. Betul tak?
Betul.
So this is a transition or what?
Transition.
Yes. Ingat tips saya. Oh, doktor ajar macam ni dan macam ni. Sorry. Macam ni, dia duduk tengah tau. Satu lagi duduk macam ni. This is a transition. You will get one positive, one negative. Easy to calculate. Alright? Okay, next. Yang next ni interference. Tengok ni interference. Okay. Wan Amirul, Haziq, are you listening? Tak dengar. Wan, tak dengar Wan. It's okay. Dengar sini, Wan. Tengok ni. In this question is an interference fit. So how do we know interference fit? Tengok dekat value ni. Tengok dekat sini. Tengok value ni. Sorry, tengok value ni. Nampak tak? You will see that the size of the shaft, the minimum size of shaft, ni tengok ni, 30.022 is bigger than 30.021. 30.021 ni is a maximum hole. Minimum size diameter of shaft is bigger than maximum size of hole. Dia duduk macam ni. Apabila dia duduk macam ni, maka dia adalah interference. Boleh? Syamil, faham tak Syamil? Did you understand? Syamil Aidil, where are you? Syamil Aidil, are you listening? Oh, ni ramai ni. Sleeping ni. Alisa, dengar tak Alisa? Nur Alisa Shazliana, dengar ke tidak? Are you listening?
Doktor.
Faham ke tak faham?
Faham, Doktor.
Okay. Mizul Mania. Macam mana nak panggil ni? Mizul, what is your name? Mizul? Mizul, Mizu. Miizul. Miizul eh? Muizul. Oh, Muizul. Muizul, are you listening? Okay. Alright. So now, I want to show something. This is one of the table, how you can read, how to calculate. Okay. I just want to show something tonight. I think there will be supposed to be section 11 and 12 or so at this class, at this time. I just want to show how we can read this table. Okay. This is table of whole basics. That's why you can see all the norm size, basic size of capital H. All this is in the zero line. The size of the shaft is varies. K6, N6, P6, S6. So how to read? If let's say diameter 30. So now you check here over 3 ni this one 30. There is two. One is here, one is here. Two value. Which one you want to use? Zuhairi. Zuhairi, which one you want to use? The top one 30 or the bottom 30?
Sorry doktor, boleh ulang balik tak soalannya?
Okay, diameter 30. Diameter 30. If let's say I give diameter 30 H7 K6. Okay, now you have two value of 30. This one and this one. Which one you want to use? The top one or the bottom one? Which one, Zuhairi? Aduh. Zuhairi, you have the answers?
Top one. The top one.
Okay, why the top one? Why the top one? Okay, I help you. Because of this. Tengok kat atas ni. Over 2. It means when you say 18 to 30, it means 30 is the value for 30 diameter. Over 30. 30 is not the value. 30 point something, 32, 31, 30.100, 100. That is, if then you take this one. So now is you pick up the top one, correct? This one. Okay, now H7 and K6. So you go straight here, ambil value ni. Okay, so this is referring to the upper value. This is referring to lower value. So if 30 H7 is mean 30 plus 0.021. Must remember multiply 0.001 mm. This one. You kena multiply dulu. Okay. And the lower is 30.000. And how about the shaft? This is a shaft, K6, small capital. The shaft will be 30 diameter plus 0.015 and lower 30 plus 0.002. Then you start to calculate. Understand? Understand, everyone? Okay, jangan lupa. Malam ni semua tam aja. Nanti kan lupa nanti. Okay. Alright. This is the whole basics. Previously, sometimes we share this one to the students. It's the same. Left and right is the same. Just this is the whole. Okay, boleh nampak kenapa dia whole kat sini? You will see this one. Kenapa whole? Basic, you see this one? Semua norm basic size of holes is been fixed at the line ni, zero line. But you can see the size tolerance of shaft is varies going up, negative to positive. This is whole basic system 4500. Okay, right. Okay, what else? Okay, same. Okay, guys. Do we have a class tomorrow? Section 5, 6, 11, 12. Oh, tak nampak. Ada kelas tak besok? Tolong jawab. Tak ada.
Tak ada.
Tak ada, doktor.
Okay. When do we bila boleh buat kelas? Besok
Wednesday,
kita nak masuk
class.
Ha?
Wednesday,
Rabu,
section
doktor.
class.
hari Rabu baru ada kelas. Lambat, tak boleh. Because your test will be on Thursday, correct?
Yes.
Yes, I need to prepare you just to make sure all of you can get higher marks. Saya tak nak student saya dapat low marks because from last semester there is a group yang mana tak berapa perform. I don't know why. Okay, there is a group, not all of them. Something wrong somewhere. I don't know why. Okay, so I want to make sure that you have a full class tomorrow or what? Besok full class tak? Bukanlah kata the class will be maybe after 5 or maybe at night 8 o'clock. Pukul berapa? Kalau petang boleh tak? 5, after 5. Any one of you yang tak boleh after 5. Kalau tak boleh buat macam ni. Because of the class ke apa, you ada class, then you buat lah. Tapi janganlah kata doktor tak boleh lah, saya ada dating. No. Dating, lepas test you nak dating. Betty, Robert, you have a class or what? Betty, you have a class?
Doctor,
Yes. What?
Doctor,
You,
tomorrow after 2 o'clock, probably most of us don't have class because of COQ session.
Oh, COQ. Yes. So possible to have at night, 8 o'clock? 8 o'clock, okay? We will do some calculation. Okay, I will give you I try to give some question, maybe late by tomorrow morning. You can have a look and we will discuss at night. 8 o'clock, please guys, tolong datang. and I give you some 8 o'clock, and also we will try to check some of the question from the past test 1 question. Okay. All right. So I think that's all for tonight. Thanks for joining, all of you. Have a nice dinner and have a nice rest and sleep. Thank you very much. Yes.
Sorry, Doctor.
Thank you, Doctor.
Okay. All right.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.